Good morning, students. Let us start the new chapter, that is chemical kinetics. It is one of the physical chemistry chapter and it is carrying totally 8 marks. Okay. What is chemical kinetics? Okay, in chemistry what happens? We will deal with mainly two types of substances. Which are those two types of substances? They are, one is ionic compounds, another one is covalent compounds. The velocity or the speed of ionic compounds is very fast. Means if you have the reactions of ionic compounds, they will undergo very fastly. They will undergo reaction very fastly. For example, the salts. What the reaction, the which reactions you will carry out in your laboratory, all are nothing but ionic compounds, with ionic compounds. Those all reactions are very fast. Even on just adding those substances, you will get the results. How the results improve? Color change agati, dissolve agati, dissolve agagilla, precipitate bardati, avella. Agin baga result bardati. Means the reactions of ionic compounds are very fast. The reactions of covalent compounds are usually slow. Usually slow means organic reactions are slow because organic reactions involves the organic compounds. Organic compounds are nothing but covalent compounds. Okay, it means in the chemistry, some reactions are fast, some reactions are slow, and some reactions are having moderate velocity also. Means they will proceed with moderate velocity or moderate speed. Okay, it means here I am only talking about velocity of the reactions or speed of the reactions. Okay, because the chemical kinetics deals with the velocity of the reactions or speed of the reactions. That is called as rate of a reaction. What that is called as? That is called as rate of a chemical reaction. Rate or velocity of a chemical reaction. Rate or velocity of a chemical reaction. ಹೌದಾ ಈ ಚಾಪ್ಟರ್ ನಾವು ಸ್ಟಡಿ ಮಾಡೋದು ಅದನ್ನ ಏನು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಅಂದ್ರೆ ರೇಟ್ ಆರ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಎ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್. ದಟ್ ಈಸ್ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್. ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಅಂತಂದ್ರೆ ಏನಂದ್ರೆ ದ ಬ್ರಾಂಚ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ ವಿಚ್ ಡೀಲ್ಸ್ ವಿತ್ ಸ್ಟಡಿ ಆಫ್ ರೇಟ್ ಆಫ್ ಅ ರಿಯಾಕ್ಷನ್ ಅಂಡ್ ಮೆಕ್ಯಾನಿಸಮ್ಸ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್. ಅಂದ್ರೆ ಇದ್ರ ಬಗ್ಗೆ ರೇಟ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ನಾವು, ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಅದನ್ನೇ ರೇಟ್ ಅಂತ ಕರೀತೀವಿ. ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ನಾವು ರಿಯಾಕ್ಷನ್ಸ್ ಎಂದು. ಆ ರಿಯಾಕ್ಷನ್ಸ್ ಏನಾಗಿರ್ಬೋದು, ದಟ್ ರಿಯಾಕ್ಷನ್ ಮೇ ಇನ್ವಾಲ್ವ್ ಅಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಆರ್ covalent compounds. It doesn't matter. We only focus on rate of a reaction or velocity of a reaction. In which branch of chemistry we will study about the rate or velocity of a reaction. This is called as chemical kinetics. Okay, it is the concept. Okay, then what is the rate of a reaction now? That is the question now. In chemical kinetics we will study about rate of a reaction or velocity of a reaction. Then what do you mean by rate of a reaction or velocity of a reaction? Okay, how do you calculate velocity of a car or speed of a car? Then calculate ಮಾಡ್ತೀರಿ ನೀವು. You have already studied in physics. Okay, means so what do you mean by velocity? I am asking the definition of velocity. Okay, the distance traveled by that object in a given time is called as velocity. Howdilla, change in distance divided by time taken is the definition or the formula for the velocity. Is it? Agar velocity is calculate ಮಾಡ್ತೀವಿ, distance traveled by an object in a given time or in a unit time. Okay, agar chemistry apply ಮಾಡಿದಾಗ how do you apply the velocity concept to the reactions? What changes, in which concept changes takes place in a reaction? That is you have to consider here. ಇಲ್ಲಿ ಚೇಂಜ್ ಎಲ್ಲ ಆಗ್ತದೆ ಅಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಚೇಂಜ್ ಆಗ್ತದೆ ಆಬ್ಜೆಕ್ಟಿಗೆ ಬಂದಾಗ ಇಲ್ಲಿ ಚೇಂಜ್ ಎಲ್ಲ ಆಗ್ತದೆ in a molar concentrations. You will observe a change. Okay? In reaction, what happens? Just assume a reaction here. R gives rise to P. What is R? Reactant. What is P? Product. Okay? At a time T1. T1 again time on that. Just try it reactant. Further, here we are having R1. What is R1? Molar concentration of R, reactant, at a time T1. Okay? It is what? Molar concentration of P at a time T1. After some time, reactants decreases, concentration of products increases. Okay? Reactants concentration decreases, product concentration increases. Now calculate at a time T2. At a time T2, it becomes R2. This becomes T2. Then rate of a reaction is given by. Even the rate of a reaction is rate of a reaction is equal to, for the reactants R2 minus R1. Is it? R2 minus R1. In which time? In this time. In this time. In T2 minus T1. Okay? This is known as delta R. This is known as delta R, change in concentration of the reactant in given time, delta T. Here you will get negative sign for this one. Negative sign for this one. Why? Because concentration of the reactants with the time decreases. Kadime agirtade niಮಗೆ ಗೊತ್ತಿದೆ reactantಗಳು ಬರ್ತಾ ಬರ್ತಾ ಕಡಿಮೆ ಆಗ್ತದೆ. Therefore we will get a negative sign here. Same thing. Rate with respect to product also we can calculate. Rate is equal to, for the products, P2 minus P1. Okay? P2 minus P1 divided by P2 minus P1. Okay? It is what? Delta P in given time. It is delta P. Here we get positive sign. Why do you get the positive sign? Because product concentration as the time passes or time reaction process, it increases. Okay? Increase again. This is what? Formula to calculate the rate or velocity of a chemical reaction. Okay? And the definition is what you need. Definition is what the rate again. Rate of a chemical reaction or velocity of a chemical reaction is defined as the change in molar concentration of a reactants. The change in molar concentration of a reactants or a products in unit time. ಕೊಟ್ಟಂತ ಸಮಯದೊಳಗ ರಿಯಾಕ್ಟೆಂಟ್ ಒಳಗಾದ್ರೂ ಆಗಿರಲಿ ಪ್ರಾಡಕ್ಟ್ ಒಳಗಾದ್ರೂ ಆಗಿರಲಿ ಏನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಚೇಂಜ್ ಆಗ್ತದಲ್ಲ ಆ ಚೇಂಜ್ ಅನ್ನು ಏನಂತಂದ್ರೆ ರೇಟ್ ಆರ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಎ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಗೊತ್ತಾಯ್ತಾ? Rate or velocity of a chemical reaction is defined as the change in molar concentration of one of the reactants or one of the products in unit time is called as what? Rate of a chemical reaction or velocity of a chemical reaction. ಗೊತ್ತಾಯ್ತು? Okay? Any doubts here? ಈ ರೀತಿ ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ rate of a chemical reaction ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. Here note in gaseous reactions. What? In gaseous reactions. Reactions ಒಳಗೆ gases ಇದ್ರೆ ಏನಂದ್ರೆ A is a gas, B is also a gas. It is forming a C, that is also a gas. In gaseous reactions, in this case, the rate of the reaction is also explained in terms of pressure. Pressure consider ಮಾಡಿಕೊಂಡು ನಾವು ಏನು ಮಾಡಬಹುದು ಇಲ್ಲಿ explanation ಕೊಡಬಹುದು. ಇಲ್ಲಿ molar concentration change ಆಗ್ತದೆ. For reactants it will decrease, for products it will increase. In case of gaseous reactions we can use the pressure concept also to explain rate of a chemical reaction. ಅವಾಗ ಏನಂತ ಹೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ the change in pressure of one of the reactants or products in unit time is called as what? Is called as what? Velocity of a reaction or rate of a chemical reaction. ಯಾಕಂದ್ರೆ ಪ್ರೆಷರ್ ಚೇಂಜ್ ಆಗ್ತದೆ ಇಲ್ಲಿ. ರಿಯಾಕ್ಟರ್ ಗಳ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆಗ್ತದೆ, ಪ್ರಾಡಕ್ಟ್ ಗಳ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ ಕೆಲವು ಗ್ಯಾಸಸ್ ಇದ್ದಾಗ. ಅಲ್ಲಿ ಈ ರೀತಿ ನಾವು ಏನು ಮಾಡಬಹುದು ಅಂದ್ರೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೊಡಬಹುದು. ಅಂದ್ರೆ ಯೂನಿಟ್ ಏನಾಗಿ ಬರ್ತದೆ ಅಂದ್ರೆ ಯೂನಿಟ್ ಏನಾಗಿ ಬರ್ತದೆ ಇಲ್ಲಿ ಯೂನಿಟ್ ಏನಾಗ್ತದೆ ನೋಡ್ರಂಗ what is the unit here? Change in molar concentration. It is expressed in moles, mole per second. Here unit is mole per second. There also, here also it is explained mole per second. Illi atmosphere per second, bar per second, Pascal per second. ಹೌದಾ? ಈ ರೀತಿ ಏನು ಮಾಡಬಹುದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್. That is average rate of a reaction. Okay, average rate of a reaction is explained by using the graphs also. It is for reactants. Okay, this one is for the products. Okay, so yeah, nature of the graph is it is decreasing, line is decreasing for the reactants. Why? Because concentration of the reactant decreases as time passes. For the products, the line is increasing. The nature of the graph is increasing. Why? Because products, as time passes, it increases. In that one, let us discuss about average rate of a reaction. What do you mean by average rate of a reaction? Average rate of a reaction, RAV, is equal to, it is nothing but ratio of change in concentration of one of the reactants or products in a given interval of time. It is what? Average rate of a reaction is nothing but the ratio of change in molar concentration of one of the reactants or one of the products in a given interval of time. ನೀನು ಕೊಟ್ಟಂತ ಸಮಯದೊಳಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನಾನು ಹೇಳ್ಬೇಕಂತಂದ್ರೆ ಒಂದು ಅಸ್ಯೂಮ್ ಮಾಡು ಏನು ಫ್ರಮ್ 30 seconds to 40 seconds ಟೈಮ್ ಒಳಗ ರಿಯಾಕ್ಷನ್ ನಡೆದತ್ತೆ. ರಿಯಾಕ್ಷನ್ ನಡೆದು 30 seconds to 40 seconds ಟೈಮ್ ಒಳಗ ಅಂದ್ರೆ ಗ್ಯಾಪ್ ಸ್ಟೇಜಲ್ಲಿ 10 seconds ಇದೆ. ಈ 10 seconds ಒಳಗ ಅಥವಾ 10 minutes ಒಳಗ ನೀವು ತಗೋಬಹುದು ಆಸ್ ಯು ವಿಶ್. In between this 10 seconds, how much change in molar concentration is happened or obtained? If you calculate change in molar concentration of the one of the reactants or products in this 10 seconds, that is what average rate of reaction. ಕೊಟ್ಟಂತ ಟೈಮ್ ಗ್ಯಾಪ್ ಒಳಗ ಇಷ್ಟೊಂದು ಟೈಮ್ ಗ್ಯಾಪ್ ಒಳಗ ನೀವು 10 seconds ತಗೋ, 10 seconds ಒಳಗೆ ತಗೋ, ಈಗ 40 to 65 seconds ಅಂತ 25 seconds ಗ್ಯಾಪ್ ಬರ್ತದೆ. ಅಲ್ಲಿ ಆ ಟೈಮ್ ಒಳಗ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ ಅಥವಾ ಪ್ರಾಡಕ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಚೇಂಜ್ ಆಗೈತಿ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಿ ಅಂತಂದ್ರೆ ಅದೇನಾಗ್ತದೆ average rate of a reaction ಆಗ್ತದೆ. ಇಲ್ಲಿ for the products, for the reactants I can calculate average rate of a reaction by using this graph. Consider at time t1, concentration of the reactants is R1. Okay, at time t2 it is R2. It is decreasing. Look at here, it is decreasing. Okay, actually now like the graph is okay, it is decreasing. It is decreasing. Okay, I'll increasing. Okay, hello. At the time t1, concentration of the reactant is R1. At the time t2, it is what? R2. Then average rate of the reaction is given by R2 minus R1 divided by T2 minus T1. Now, okay, we were discussing average rate of reaction. Average rate of reaction is given by now delta R divided by delta T. Okay, it becomes average rate of reaction. What is delta R here? This difference is delta R now. This difference is the delta R. This difference is delta T in the graph. Same thing is for average rate of reaction for products is calculated as T2 minus T1 divided by again T2 minus T1 is equal to delta P divided by delta T. What is delta P here? This difference. Is it? This difference itself is delta P. Is it? Here in graph, this difference is delta T. Okay, it is what? Average rate of a reaction. But actually what happens? In chemistry, there is no importance for the average rate of a reaction. Average rate of reaction is not importance. Why? Because rate of a reaction changes at every second. Prati second it change ಆಗ್ತದೆ. Now the average rate of reaction an example ಕೊಟ್ಟೆ. Look at here. If you calculate the rate of reaction between this 10 seconds, ಈ 10 seconds ಗಳ ಮಧ್ಯೆ ನಾನು ಚೆಕ್ ಮಾಡಿದ್ರೆ ಅದೇನು average rate of reaction for products as well as for the reactants. ನೀವು ಇದನ್ನ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಆಗುತ್ತೆ. For the reactants you will get the negative value. For the products you will get the positive value. That is the difference. Negative value indicates that molar concentration is decreasing. Positive sign indicates that molar concentration is increasing. ಇಷ್ಟ ವ್ಯತ್ಯಾಸ ಅಷ್ಟು ಬಿಟ್ಟರೆ ಮತ್ತೇನು ಚೇಂಜಸ್ ಇಲ್ಲ. ಈ 10 ಸೆಕೆಂಡ್ಸ್ ಒಳಗೆ ಎಷ್ಟು ವ್ಯತ್ಯಾಸ ಆಗ್ತದೆ ನನಗೆ ಅದನ್ನು ನೀವು ಚೆಕ್ ಮಾಡಿದ್ರೆ 10 ಮಿನಿಟ್ಸ್ ಒಳಗೆ ಎಷ್ಟು ವ್ಯತ್ಯಾಸ ಆಗ್ತದೆ ಅದನ್ನು ಚೆಕ್ ಮಾಡಿದ್ರೆ that is what average rate of reaction for the reactors as well as for the products. ನನಗೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ. ಈಗ ನೋಡಿ ಒಂದು ವೆಹಿಕಲ್ ಮೂವ್ ಆಗ್ತದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಅದರ ವೆಲಾಸಿಟಿ ಏನಾಗ್ತದೆ ಪ್ರತಿ ಸೆಕೆಂಡ್ ಚೇಂಜ್ ಆಗ್ತದೆ. For every second velocity of an object, moving object will change. Similarly, the velocity of a chemical reaction also changes with respect to reactants as well as with respect to products. It will change at every second. That is important. ಅದು ಮುಖ್ಯ. ನಮಗೆ every second change ಆಗ್ತದೆ. ಅಂದ್ರೆ every second change ಆಗೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಹೆಂಗಂದ್ರೆ I don't need the rate of reaction in between these seconds. I need at this point. ಇಲ್ಲಿ ಎಷ್ಟೋ ಇದು ಪಾಯಿಂಟ್, ಈ ಪಾಯಿಂಟ್ ಎಷ್ಟು ಆಗುತ್ತೆ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ನನಗೆ ಅದು ಬೇಕಾಗ್ತದೆ. ಈಗ ನೋಡ ಇಲ್ಲಿ ಎಷ್ಟು ತಂದ್ಕೊಡಿ ಒಂದು 10 ಸೆಕೆಂಡ್ಸ್ ಐತೆ ಅನ್ಕೋಬೇಕು. 10 ಸೆಕೆಂಡ್ ಬಿಟ್ವೀನ್ 10 ಸೆಕೆಂಡ್ ಅಲ್ಲ ನಾನು ಬೇಕಾಗಿತ್ತು 10 ಸೆಕೆಂಡ್ ಆಗಬೇಕಾಗ ಎಷ್ಟೈತಿ ನನಗೆ ಅದು ಬೇಕು. ಹಿಯರ್ ಆಲ್ಸೋ ಐ ವಾಂಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ the rate of reaction for the products at that point. If you calculate the average rate of reaction, you will get the rate of reaction in between this time. ನಿಮಗೆ ಈ ಟೈಮ್ ಒಳಗೆ ಸಿಗ್ತದೆ ನನಗೆ ಆ ಟೈಮ್ ಒಳಗೆ ಬೇಕಾಗಿಲ್ಲ, ಈ ಟೈಮ್ ಎಷ್ಟು ಐತಿ ನನಗೆ ಅದು ಬೇಕಾಗಿಲ್ಲ. That is called as what? Instantaneous rate of reaction. That is important. Instantaneous rate of a reaction. What is instantaneous rate of reaction? The change in the molar concentration of one of the reactants or a products with a time at a particular time. At a particular time point from the point is 40 seconds. ಆ 40 ಸೆಕೆಂಡ್ಸ್ ಎಷ್ಟು ಇದೆ? ಇನ್ ಬಿಟ್ವೀನ್ 40 ಸೆಕೆಂಡ್ಸ್ ಅಲ್ಲ ನಾನು ಹೇಳತ್ತಿದ್ದು, ಎಕ್ಸಾಕ್ಟ್ 40 ಸೆಕೆಂಡ್ಸ್ ಎಷ್ಟು ಇಲ್ಲಿ ನೋಡಿ. ಇನ್ ಬಿಟ್ವೀನ್ 10 ಸೆಕೆಂಡ್ಸ್ ಆಗ್ತಿದ್ದು 30 ಮೈನಸ್ ಸೆಕೆಂಡ್ಸ್ ಇಂದ 40 ಸೆಕೆಂಡ್ಸ್ ಗಳು ಚೆಕ್ ಮಾಡಿದ್ರೆ ಅದು ಇನ್ ಬಿಟ್ವೀನ್ ನನಗೆ ಅದು ಬೇಡ. ಈ 40 ಸೆಕೆಂಡ್ ಆದಾಗ ಎಷ್ಟು ನನಗೆ ಅದು ದಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾಕಂದ್ರೆ ಎವ್ರಿ ಸೆಕೆಂಡ್ ಚೇಂಜ್ ಆಗ್ತದೆ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್. ಹೌದಾ? ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾನು ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅಂದ್ರೆ ಗ್ರಾಫಿಕಲಿ ಅವರು ಚೆಕ್ ಮಾಡೋದು ಹೆಂಗಂದ್ರೆ ಹೌ ಡು ಯು ಚೆಕ್ ಗ್ರಾಫಿಕಲಿ that one? See, if I want to get instantaneous rate of reaction at this point I need to draw a tangent here. What I need to draw? I need to draw a tangent. Okay, you need to get the slope of that tangent. The slope of that tangent will give you the instantaneous rate of reaction. ನಿಮಗೆ ಗೊತ್ತೈತೆ, ನೀವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಒಳಗೆ ಕಲ್ತಿರ್ತೀರಿ, ಒಂದು ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಿರೋ ಪಾಯಿಂಟ್ ಒಳಗೆ. ಹೌದಾ? ಬೇಕಾದ್ರೆ ನೀವು ಇಲ್ಲೂ ಡ್ರಾ ಮಾಡ್ಬೋದು. ಡ್ರಾ ಎ ಟ್ಯಾಂಜೆಂಟ್ ಹಿಯರ್. If you get the slope of that tangent, ಹೌದಾ? ನೀವು ಆ ಟ್ಯಾಂಜೆಂಟ್ ಸ್ಲೋಪ್ ನ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಹಿಯರ್ ಐ ವಿಲ್ ಗೆಟ್ ದಟ್. ಇದೊಂದು ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಕ್ಕಲ್ಲ. ಓಕೆ, ನಾನು ಇದನ್ನ ಡ್ರಾ ಮಾಡಬೇಕಂದ್ರೆ ಈಗ ಹಿಯರ್ ವಾಟ್ this difference is called as what? dy or dr. Okay, this difference is called as what? This difference is called as dt. What is dt? It is a change in a small interval of time. What is dr? Change in the molar concentration of the reactant at a small interval of time. Some change ನೋಡೋದು ಎಷ್ಟು ಆಗ್ತದೆ. Here also I can calculate same here. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಮಾಡಿ ಡ್ರಾ ಮಾಡಿ ಒಂದು ಏನು ಡ್ರಾ ಮಾಡ್ತೀರಿ? Is it? ಸ್ಲೋಪ್ ನ ಡ್ರಾ ಮಾಡಬಹುದು. ನಿಮಗೆ ಗೊತ್ತೈತೆ ಸ್ಲೋಪ್ ಬಗ್ಗೆ ನಾನು ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಜಾಸ್ತಿ ಕೊಡಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಒಳಗೆ ಕಲ್ತಿರ್ತೀರ ಹಂಗಾದ್ರೆ. ಹೌದಾ? ಇಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬರ್ತೈತಿ. This difference is what? dt. Okay, this difference is what? dt. ಈ ಡಿಫರೆನ್ಸ್ ಏನಂದ್ರೆ dt. ಹೌದಾ? ಈ ಡಿಫರೆನ್ಸ್ ಅಂತ ನೀವು ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳೋದು. This difference is what? It is what? dt. A small difference. Okay, hanga instantaneous rate of reaction. How do you define instantaneous rate of reaction? R instantaneous is equal to what? dr divided by dt. Okay, or R instantaneous is given by dp divided by dt. Okay, andre you ಏನು ಮಾಡ್ತೀವಿ ಡೈರೆಕ್ಟ್ ಆಗಿ you are now applying the differentiation here. Nothing but you are going to apply differentiation. ಅಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಈ ಪಾಯಿಂಟ್ ಒಳಗೆ ಎಷ್ಟು ಐತಿ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ನಿಮಗೆ ಸ್ಲೋಪ್ ಬಗ್ಗೆ ನಾಲೆಜ್ ಆಯ್ತು ಅಂತ ಅನ್ಕೋತಾರೆ. ನಾನು ಫಸ್ಟ್ ಪೀಸ್ ಒಳಗೆ ನೀವು ಕಲ್ತಿರ್ತೀರಿ, ಅದಕ್ಕೆ ನಾನು ಇನ್ ಡೀಟೇಲ್ ಹೋಗ್ತಾ ಇಲ್ಲ. ಆ ಪಾಯಿಂಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರಿ ಗ್ರಾಫ್ ಒಳಗ ಅದಕ್ಕೆ ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡ್ರಿ. The tangent, the slope of that tangent you have drawn at that point will be what? The instantaneous rate of reaction. Here, this dr by dt is equal to a negative slope. Is it? You will get a negative slope here. It is decreasing. Rate is concentration is decreasing here, but here you will get a positive slope according to the diagram. Is it? This much is the importance here. This is the difference between average rate of reaction and instantaneous rate of reaction. What is instantaneous rate of reaction? The change in molar concentration of one of the reactants or products with a time at a particular time is called as instantaneous rate of reaction. ಅಂದ್ರೆ ಏನು? ನನಗೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಈ 40 ಸೆಕೆಂಡ್ಸ್ ಬಂದಾಗ ಎಷ್ಟು ನನಗೆ ಅದು ಬೇಕು, ಈ 50 ಸೆಕೆಂಡ್ಸ್ ಬಂದಾಗ ಎಷ್ಟು ಐತಿ ನನಗೆ ಅದು ಬೇಕು. In the between 40 to 50 seconds ಬೇಡ ನನಗೆ. 46 ಸೆಕೆಂಡ್ ಆದಾಗ ಎಷ್ಟೈತಿ, 45 ಸೆಕೆಂಡ್ ಆದಾಗ ಎಷ್ಟೈತಿ, 49 ಸೆಕೆಂಡ್ ಆದಾಗ ಎಷ್ಟೈತಿ, ನನಗೆ 49 to 50 seconds ಬೇಡ, ಆ 1 ಸೆಕೆಂಡ್ ವ್ಯತ್ಯಾಸ ಐತೆ ನೋಡ್ರಲ್ಲಿ, ನನಗೆ ಆ 1 ಸೆಕೆಂಡ್ ವ್ಯತ್ಯಾಸನೂ ಬೇಡ. ಎಕ್ಸಾಕ್ಟ್ 49 ಸೆಕೆಂಡ್ ಇದ್ದಾಗ ಎಷ್ಟೈತಿ, 50 ಸೆಕೆಂಡ್ ಇದ್ದಾಗ ಎಷ್ಟೈತಿ, 51 ಸೆಕೆಂಡ್ ಆದಾಗ ಎಷ್ಟೈತಿ, ನೀನು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಒಳಗೆ ಚೆಕ್ ಮಾಡಿದ್ರೆ ದಟ್ ಇಸ್ ವಾಟ್ instantaneous rate of reaction. In chemical kinetics, this instantaneous rate of reaction is important, not average rate of reaction. Average rate of reaction ನಮಗೆ ಮುಖ್ಯ ಅಲ್ಲ, ಯಾಕಂದ್ರೆ ಇನ್ನು ಬಿಟ್ವೀನ್ ಈ 10 ಸೆಕೆಂಡ್ನ ಮಧ್ಯೆ ಎಷ್ಟೈತಿ, ಈ 15 ಸೆಕೆಂಡ್ನ ಮಧ್ಯೆ ಎಷ್ಟೈತಿ, ಈ 1 ನಿಮಿಷ ವ್ಯತ್ಯಾಸಗಳು ಅಂದ್ರೆ 60 ಸೆಕೆಂಡ್ಗಳ ಮಧ್ಯೆ ಎಷ್ಟೈತಿ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಈಸಿ ಐತಿ, ಇಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಐತೆ ನೋಡಿ. dr divided by dt ಅಂತ ಡೆಲ್ಟಾ r divided by ಡೆಲ್ಟಾ t ಅಂತ ಹೇಳ್ತಾರೆ ನಾವು. ದಟ್ ಇಸ್ ಇನ್ ದಟ್ ಡಿಫ್ರೆನ್ಸ್ ಅಷ್ಟು ಟೈಮ್ ಒಳಗೆ ಎಷ್ಟು ಅಂತೇಳಿ ನನಗೆ ಅದು ಬೇಡ, ಆ ಪಾಯಿಂಟ್ ಒಳಗೆ ಎಷ್ಟು ಬೇಕಾಗಿತ್ತು ನನಗೆ. ಹೌ ಡು ಯು ಗೆಟ್ ದಟ್? ಬೈ drawing a tangent at a particular time. If you get the slope of that tangent drawn at a particular time, you will get instantaneous rate of a reaction. This is about average rate of reaction and instantaneous rate of a reaction. The next concept is factors influencing rate of a reaction. Angare ಯಾವ ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ rate of reaction dependent ಆಗಿರುತ್ತೆ. First one, concentration of reactants. On concentration of reactants, rate of reaction depends. Next one, on temperature. On temperature, rate of reaction depends. And third one is catalyst. And third one is catalyst. In case of here also I can take pressure. On pressure also the rate of reaction depends. But this pressure concept is applicable for only gases. If reactants are gases, then only you can apply the pressure. Otherwise, there is no effect of the pressure on the reactants. Then we have to go for the concentration, molar concentration. In the concentration of the apply ಮಾಡಿದ್ರೆ solid ಅಥವಾ liquid ಆದಾಗ our reactants gases ಆದಾಗ concentration ಅನ್ನೋದಿಲ್ಲ ಅಲ್ಲಿ, ಅಲ್ಲೇ pressure ಬರುತ್ತೆ. Okay, on these three factors the rate of reaction increases. Okay, now let's discuss about first point, that is what? Rate dependence. On concentration of reaction. On the concentration of the reaction. Reaction concentration ಮೇಲೆ rate ಯಾವ ರೀತಿ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ ನೋಡೋಣ. ಓಕೆ, ಅಕಾರ್ಡಿಂಗ್ ಟು ಲಾ ಆಫ್ ಮಾಸ್ ಆಕ್ಷನ್. Law of mass action. If you consider a reaction A plus B give rise to C plus D. Okay, here let us write A, B, C, D. Capital terms, capital A and B are the reactants. Capital C and D are the products. Then what are small a and small b? Are stoichiometric coefficients of the reactants. Okay, C and D are stoichiometric coefficients of the products. Okay, according to law of mass action, first PUC olaga equilibrium chapter olaga kaltirni, rate of a reaction is directly proportional to law of mass action. We have already studied in the first PUC of the equilibrium chapter. The law states that E law prakara rate of a reaction is directly proportional to active masses of the reactants. It is the statement given in the law of mass action. Active masses of the reactants means what? Product of molar concentration of the reactants. Product of molar concentration of the reactants. It is on product of molar concentration of the reactants, rate of reaction depends. ಇದರ ಅರ್ಥ ಏನು? molar reactant molar concentration ಜಾಸ್ತಿ ಇದ್ರೆ rate of reaction ಜಾಸ್ತಿ ಇರುತ್ತೆ. rate of reaction ಏನಾಗ್ತದೆ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಇದು ಕಡಿಮೆ ಇದ್ರೆ ಇದು ಕಡಿಮೆ ಇರುತ್ತೆ ಅಂದ್ರೆ it means on the concentration of the reactants the rate of the reaction directly depends. This is the meaning of the law of mass action. This is what mathematical form of the law of mass action. Rate is directly proportional to product of molar concentration of the reactants. Okay, and rate ಯಾವ ರೀತಿ ಡಿಪೆಂಡೆಂಟ್ ಇರುತ್ತೆ? ರೇಟ್ ಯಾವ ರೀತಿ ಡಿಪೆಂಡೆಂಟ್ ಇರುತ್ತೆ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಡೈರೆಕ್ಟ್ಲಿ ಡಿಪೆಂಡ್ಸ್. ಇದರ ಅರ್ಥ ಏನು? as the time passes concentration of the reactant decreases. As concentration of the reactant decreases, rate also decreases. ಅಂದ್ರೆ ಇನಿಷಿಯಲಿ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಎಷ್ಟಿರ್ತದೋ ಅದು ಮುಗಿಯುವವರೆಗೂ ಅಷ್ಟೇ ಇರಂಗಿಲ್ಲ. ಮುಗಿಯುವಾಗ ಅಷ್ಟೇ ಇರಂಗಿಲ್ಲ ಅಂದ್ರೆ ಕಡಿಮೆ ಆಗ್ಕೊಂತ ಹೋಗ್ತದೆ. ಬರ್ತಾ 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 ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಪ್ರೊಡಕ್ಟ್ಸ್ with respect to reactants decreases. ಗೊತ್ತಾಯ್ತು ನಂಗರ? ಯಾಕೆ ಹೇಳಿ? as time passes concentration of the reactant decreases. As concentration of the reactant decreases, rate also decreases. It means rate of reaction in the beginning of the reaction is not equal to rate of reaction at the middle position of the reaction or end point of the reaction or somewhere in between the reaction. Rate of reaction is always higher at the beginning of the reaction. As the time proceeds, as the reaction proceeds, as time passes or reaction proceeds, as the reaction proceeds, rate of reaction decreases. Yake? Concentration of the reactant decreases. Is it? Okay. This is about rate dependence on concentration of the reaction. Next concept, rate law expression. This is important in this chapter. Rate law expression. Already we have studied that the rate of a reaction is directly proportional to product of molar concentration of the reactants. For which reaction? For reaction A plus B gives rise to C plus D. Okay, here small a is stoichiometric coefficient of the A, small b is stoichiometric coefficient of the B, small c and small d are stoichiometric coefficients of the C and D respectively. Okay, here what is rate law expression? Rate law expression is given by rate is directly proportional to molar concentration of A raised to the power x and molar concentration of B raised to the power y. This is what rate law expression. Okay, then what are x and y? X and y are exponential terms. Exponential terms. These x and y may be equal to A and B, and or x and y may not be equal to A and B. This may be equal or may not be equal. This is what? This rate equation is directly proportional to molar concentration of A into molar concentration of B raised to the power x and y. Okay, this equation can be written as this rate is equal to dr by dt. Okay, this is equal to k into molar concentration of A raised to the power x and molar concentration of B raised to the power y. Okay, this x and y, exponential of x and y may be equal to stoichiometric coefficients present in the balanced chemical equation or may not be equal to stoichiometric coefficients. Okay, that is important. What is k here? K is rate constant. Rate of a reaction changes at every second of the time, every second of the reaction, but rate constant throughout the reaction remains same. Please remember this point. Rate constant of a reaction is a constant throughout the reaction for a particular reaction, but the rate of a reaction, this rate of a reaction will change. Okay, x and y change agati ಅಂದ್ರೆ what is rate law, rate expression ಅಂತ ಕೇಳ್ತಾರೆ. ಏನಂತ ಬರೀತೀರಿ law ಅಂದ್ರೆ rate law expression is defined as the product of molar concentration of the reactants. Product of molar concentration of the reactants. Each term rises to some powers. Each term rises to some powers which are maybe equal or not equal to stoichiometric coefficient present in a balanced chemical equation. This statement is called as what? Rate law expression. Okay, or rate law. ಹೌದಾ? ಇದನ್ನ ಏನು ಡಿಫೈನ್ ಮಾಡ್ತಿರಲ್ಲ ಈಕ್ವೇಷನ್ ನ, ಇದನ್ನ ಏನಂತ ರೇಟ್ ಲಾ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಥವಾ ರೇಟ್ ಲಾ ಅಂತ ಕರೀತೀವಿ. ಸ್ಟೇಟ್ಮೆಂಟ್ ಒಳಗೆ ಹೇಳಿದ್ರೆ ರೇಟ್ ಲಾ ಅಂತ ಅಂತಾರೆ. ಅಂದ್ರೆ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಎ ಅಂಡ್ ಬಿ ಈಕ್ವಲ್ ಆಗಿರೋದಿಲ್ಲ. ಯಾಕೆ ಅಂದ್ರೆ ಸಿ ಕನ್ಸಿಡರ್ ಎ ಜನರಲ್ ರಿಯಾಕ್ಷನ್ a plus b given as to c plus d. Okay, I will just double the concentration of A only. Concentration of A na double ಮಾಡಬೇಕು. ಆವಾಗ ರೇಟ್ ಏನಾಗ್ತದೆ? ರೇಟ್ ಡಬಲ್ಸ್ ಅನ್ಕೊಡ್ರಿ. ನೀನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ A ನ ಡಬಲ್ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ಅಂದ್ರೆ 10 ಮೋಲ್ ಇದ್ದರೆ 20 ಮೋಲ್ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ಡಬಲ್ ಆಗ್ತಿದೆ ಅಂತ. ಹೌದಾ? ರೇಟ್ ಕೂಡ ಡಬಲ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಇಫ್ ಯು ಡಬಲ್ concentration of B, if you double concentration of B, then rate increases by 4 times. Experimentally prove ಆಗ್ತದೆ. ಅಂದ್ರೆ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡೇನೆ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ನೀನು A ನ ಡಬಲ್ ಮಾಡಿದಿ, ರೇಟ್ ಡಬಲ್ ಆಯ್ತು. ನೀನು B ನ ಡಬಲ್ ಮಾಡಿದಿ, A ನ ಹಾಗೆ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು, ಹೌದಾ? ಅವಾಗ ಏನಾಗ್ತದೆ, ರೇಟು 4 ಟೈಮ್ಸ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡು x and y ಏನು ಬರ್ತದೆ ಈಗ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಫಾರ್ A okay, rate is doubled under 2. Rate is doubled 2. Okay, look, for A rate is directly proportional to molar concentration of A raised to the power x. Okay, ಈಗ apply ಮಾಡಿ. Rate is doubled ಯಾವಾಗ? and molar concentration of A is doubled. What is x? 2 is equal to 2 raised to x. So what is x? X is equal to 1. Is it? X is equal to 1 ಆಗ್ತದೆ. For A, x value is 1. Okay. For B, rate is equal to molar concentration of B raised to the power y. Experimental ನಾವು ಏನು ತಗೊಂಡೇವೆ? Rate increases by 4 times. If you double the concentration of B, ಕಾನ್ಸಂಟ್ರೇಷನ್ B ನ ಡಬಲ್ ಮಾಡು, ರೇಟ್ 4 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಹೌದಾ? ಹಂಗಂದ್ರೆ ರೇಟ್ ಇನ್ಕ್ರೀಸಸ್ ಬೈ 4 ಟೈಮ್ಸ್ when concentration of B is doubled. Then what is y? Y is equal to 2. Y is equal to 2. ಹೌದಲ್ಲ? ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಏನೈತಂದ್ರೆ ಆಕ್ಚುಲಿ ಹಿಯರ್ 1, B is also 1. According to the balanced chemical equation, A is 1, B is 1. Okay, but x is what? 1, y is 2. Y is 2. ಯಾಕಂತಂದ್ರೆ ನೀವು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ B ನ ಡಬಲ್ ಮಾಡಿದ್ರೆ ರೇಟ್ 4 ಟೈಮ್ಸ್ ಡಬಲ್ ಆಗ್ತದೆ. ರೇಟ್ ಏನಾಗ್ತದೆ? 4 ಟೈಮ್ಸ್ ಡಬಲ್ ಆಗ್ತದೆ. ಆದ್ರೆ A ಡಬಲ್ ಮಾಡೋ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗ್ತದೆ, ಇದು ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಏನಾಗ್ತದೆ? 2 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಡಬಲ್ ಆಗ್ತಾ ಇದೆ. ಅಂದ್ರೆ ಸ್ಟೊಯಿಕಿಯೋಮೆಟ್ರಿ ಮೇಲೆ ರೇಟ್ ಡಿಪೆಂಡ್ ಇರಬಹುದು, ಇರದೇನೂ ಇರಬಹುದು ಅಥವಾ ಇರದೇನೂ ಇರಬಹುದು. ಹಿಂಗೆ ಆಗ್ತದಂದ್ರೆ ದಿಸ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಡಿಸೈಡ್ಸ್ ದಟ್ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್. ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಆರ್ ಡಿಸೈಡಿಂಗ್. ಅಂದ್ರೆ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಯಾಕೆ ಡಿಸೈಡ್ ಮಾಡ್ತಾ ಹೋಗಂದ್ರ ಅದನ್ನ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಐ ವಿಲ್ give one example here. How that? Consider this reaction. N2O5 will give rise to NO2 plus O2. Okay, if you balance this one, this is the balancing equation. Okay, according to this equation, x you should have as a 2. Okay, hangandra idar prakara enagadre iga rate of a reaction is equal to molar concentration of N2O5 raised to power 2. Raised to power 2 ಬರಬೇಕು 2 ಐತಿ ಇಲ್ಲಿ. But actually, experimental rate of a reaction is the equation is given by N2O5 raised to the power 1 ಆಗಿರುತ್ತೆ. Raised to power 1 ಆಗಿರುತ್ತೆ. ಯಾಕೆ ಹಿಂಗೆ ಅಂತಂದ್ರೆ it is not 2, it is 1. ನಾನು ಆಗ ಹೇಳಿಲ್ಲ x and y may be equal to a and b or may not be equal to a and b. ಇಲ್ಲಿ 2 ಗೆ ಇದು ಸಮ ಇಲ್ಲ. ಬಂದಿಲ್ಲ ಇದು. ಯಾಕೆ? we have to go for the mechanism. ಇಲ್ಲಿ mechanism ನೋಡಬೇಕಾಗ್ತದೆ ಹೇಳಿದ್ರೆ ಏನಾಗುತ್ತೆ mechanism? It involves the 2 steps. Step number 1 consider one. Step number 1 ಒಳಗೆ ಏನಾಗ್ತದೆ? This N2O5 will split up into NO2 plus NO3. It will split up into NO2 plus NO3. In step number 2, this N2O5 again reacts with this NO2. This NO2 ಏನಾಗ್ತದೆ ಅಂದ್ರೆ ಈ ರಿಯಾಕ್ಷನ್ ಜೊತೆಗೆ ಅದು ರಿಯಾಕ್ಟ್ ಆಗ್ತದೆ. Sorry, here it will react with NO3. It will react with, means one more N2O5 reacts with this NO3. Then you will get NO2 plus oxygen. NO2 plus oxygen. See here. This NO3 gets cancelled. ಯಾಕೆ? ನೀವು overall reaction calculate ಮಾಡಿದಾಗ what is the overall reaction? Overall reaction 2N2O5 ಹೌದಾ? 2N2O5 give rise to NO2 plus O2. NO2 plus O2. See here, to balance this one, ಇದನ್ನು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಂತಂದ್ರೆ 3 ಇಲ್ಲಿ 3 ಬರ್ಕೊಡಿ ಹೌದಾ? Then 5 plus 3. Wait. Yes, oxygen is already balanced. 3 plus 1 it is 4. Okay, it is an overall reaction. This overall reaction is nothing but this reaction. Okay, ಇಲ್ಲಿ important ಏನಂದ್ರೆ important thing actually this is a slower step of the reaction. This is a faster step of the reaction. Mechanism ನೋಡಿ ಗೊತ್ತಾಗುತ್ತೆ. ಇದು mechanism ಅಂದ್ರೆ ಎರಡು ಸ್ಟೆಪ್ ನಡೆಯುತ್ತೆ. First one is slow step, second one is fast step. ಈ reaction ಈ splitting ಈಗ ಅಂತ. Okay, rate of reaction. ನಮ್ಮ rate ಬಗ್ಗೆ ಬರ್ತದೆ ನಮಗೆ. This rate of reaction for this reaction is molar concentration of N2O5 raised to power 1 ಐತಿ. ಯಾಕೆ 1 ಬಂತಂದ್ರೆ rate of reaction always depends upon slower step of the mechanism. It depends upon slower step of the mechanism. In a slower step, only one N2O5 molecule is there. Not 2 molecules of N2O5 are there. ಒಂದೇ ಒಂದು N2O5 ಐತಿ. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಒಂದೇ ಒಂದು N2O5 ಇರೋದ್ರಿಂದ exponential value is 1, not 2. ಇಲ್ಲಿ ಏನಾದರೂ 2 N2O5 ಬಂದ್ಬಿಟ್ಟಿದ್ರೆ ಇಲ್ಲಿ exponential value 2 ಬರ್ತಿತ್ತು. exponential value ಕೂಡ ಬರ್ತಿತ್ತು 2 ಬರ್ತಿತ್ತು. ಗೊತ್ತಾಗುತ್ತೆ ಅಂತದ್ದು. Okay, means to decide rate law or rate expression, just balancing the reaction, we can't give the rate expression. By only doing the experiment By observing the each steps of the mechanism, we can decide the rate expression. ಗೊತ್ತಾಯ್ತದಲ್ಲ? ವಾಟ್ ಈಸ್ ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್? ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಂದ್ರೆ ಏನು? ಆಗ ಹೇಳ್ತೀನಿ ನಾನು. ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಐತಿ. Rate law or rate expression is the rate of reaction is directly proportional to molar product of molar concentration of the reactants. Each term rises to some powers which are may be equal to or may not be equal to stoichiometric coefficient of the balanced chemical equation. ಅದು equal ಇರಬಹುದು, ಇರದೇನು ಇರಬಹುದು. ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತದೋ? ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ಸ್ಲೋವರ್ ಸ್ಟೆಪ್ ಆಫ್ ದ ಮೆಕ್ಯಾನಿಸಮ್. ಮೆಕ್ಯಾನಿಸಮ್ ಸ್ಲೋ ಸ್ಟೆಪ್ ಒಳಗ ನಿನಗೆ ಬೇಕಾದಂಥ ಮಾಲಿಕ್ಯೂಲ್ ಅಥವಾ ರಿಯಾಕ್ಟೆಂಟ್ ಎಷ್ಟು ನಂಬರ್ ಒಳಗೆ ಐತಿ ಅನ್ನೋದೇ ಏನು? ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ ಮೀನ್ಸ್ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್.